In one of the first lectures, we said that there were two main advancements that made transformers very popular. One was attention mechanism, which we saw in the previous lecture. Today, we will delve in transfer learning. We will see what transfer learning is. We will see one of the most popular framework for transfer learning named ULM-FIT. And we will start having a look in one of the most popular libraries that are allowing transformers to become so popular, which is the Hugging Face Transformers library. What transfer learning is? Transfer learning is a machine learning approach where knowledge, which was gained from training a model on one task, is applied to a different but related task. It involves the use of pre-training model from a source task to solving a target task. Transfer learning focuses on leveraging the knowledge acquired by model trained to accomplish one task and to operate in a different but related task. This second task, the target task, often has limited label data. And indeed, transfer learning is in contrast with supervised learning, where the model, as we have seen, is trained using labeled example to learn the function that make prediction on unseen data. Let's see this with a graph. In supervised learning, we have two different models trained of two different domains with two different datasets, and they make separated prediction. On the other hand, in transfer learning, we transfer the body and the head of the model into the new domain, and the first model initializes the second model. During the 2017 and 2018, there were various research groups that introduced methods to enable transfer learning, but these methods they were not really powerful. One of the first notable approach in transfer learning has been ULM-FIT, which paper you can find at the link in the slides. ULM-FIT introduced a very versatile framework for adapting pre-trained model to different tasks. ULM-FIT consists of three steps. The first step of UML is the pre-training. The initial training objective in this phase is quite simple. The model needs to learn to predict the next word based on the previous word. This task is called language modeling. The elegance of this approach lies in the fact that you don't need labeled data because you need to predict the next word. And one can make use of very abundant text available from several sources. For example, Wikipedia. A subsequent step is domain adaptation. Once the language model is pre-trained on a very large-scale dataset, the next step is to adapt the language model into a different but still similar domain. For example, we can transfer the knowledge of Wikipedia into the IMDb corpus of movie reviews. This stage still uses language modeling techniques, but now the model has to predict the next word in the target dataset. And in the last step, we fine-tune a classifier. The language model in this last step is fine-tuned with the classification layer for the target task that will accomplish the task that has been supposed to. In this case, classifying the sentiment of movies reviews. Some consideration about ULM-FIT. ULM-FIT made transformer very popular by providing an effective framework for pre-training and transfer learning. And why this? This is mostly because huge amount of data were used to pre-train model on a very large scale, and we could use this model really in a simple way. For example, GPT uses the decoder, as we have seen previously, and employs the same language modeling that ULM-FIT employs. GPT was in fact pre-trained on the book corpus, which is a dataset containing 7,000 unpublished books across different topics. BERT, that used the encoder for architecture, as we have seen, employs what is called the masked language modeling that involves predicting randomly masked words in a text. BERT was also pre-trained on the book corpus, but in addition, it's pre-trained also on the Wikipedia. Using LLMs across different applications was challenging until a few years ago. And this was because many researchers used several different frameworks to develop LLMs. Some of them used PyTorch, some of them used TensorFlow, some of them use other frameworks. The Hugging Face Transformer library offers a unified framework that supports over 20,000 different LLMs. The library is playing a vital role in accelerating the research on transformer, in developing new applications, and to facilitate seamless integration of LLMs into many different real-life applications. What we have learned in this lecture? We have seen the transfer learning approach, which uses the knowledge of a model trained on a very big dataset, transfer to a different but still similar task using minimal training effort. ULM Fit made transformers very popular by providing an effective framework for pre-training models and for transfer learning. The Hugging Face Transformers library offers a unified framework supporting different LLMs and facilitating seamless integration of this model into numerous real-life applications.